right, with these notes, you're going to be learning about the introduction to the next unit, which is known as polynomials. It is a funny word to say, but it's not that difficult. You'll get actually very well spoken with it, and you'll know all kinds of words that have the same root in it. All right, so these notes are going to be your note taker. You're going to fill in what I fill in, and then whatever I don't fill in, you're responsible for completing and bringing to class the next time I see you. All right, we're going to start with the front side being all definitions, and that's really what you got to start off knowing. If you don't understand what a word's called and what it's going to look like, then doing anything else I give you later on is just not going to work for you. All right, so in general, a polynomial is an expression, so we have no equal signs involved, which is the sum, S-U-M, not S-O-M-E, of terms of the form ax to the k power, where k is a positive integer. So what all of this means in fancy math language is that the a is a coefficient, the x is the letter x, and the k has to be an exponent that's positive. And it's going to be a whole bunch of them added and subtracted together to string out and make one big old long expression. Right. With polynomials, you have a standard form, and it must be in the correct format and done the correct way, or it is considered incorrect. Right. So standard form for these guys are where the terms are placed in descending order from largest degree to smallest degree. So essentially what that means is that you are rearranging them and putting them order from highest exponent to lowest exponent, and it must remain in that order. So what I'm getting ready to show you is one polynomial that is written correctly in standard form, and then we will label and identify certain key parts from it. So the first thing I need you to do is copy it down correctly, and then we'll talk about its parts that I identify for you. Okay, so we have 3x to the fourth power plus 2x to the third power minus 5x squared plus 7x plus 4. This is one polynomial. This is one expression, right? But in this expression, there are a lot of different things that we need to know about. You already know about some of them, right? But some of the newer stuff will also emerge. Right, the very first thing I want you to remember or to know about is this number right in the front. The number that is in front of a variable is called the coefficient, and the number that's in front of the entire expression when it's in standard form is called the leading coefficient, because it leads the whole thing. I like to think of it as the train. It's the engine of the train. It's leading the train. Okay, so that's your leading coefficient. Okay. Along with that train analogy, the number in the very back, which happens to be my positive 4, that has no variable attached to it, is just a number, and you should know that by now. That is known as a constant. Right? Numbers without variables are known as constant. I like to call that the caboose of the train. So your leading coefficient is always attached to the highest power in the front, and the constant is always bringing up the rear of your answer in the back. Along the way with that, you're going to see these little exponents that are all stuck in here. The 4, the 3, the 2, and there's even an invisible 1 right here that's included. Every exponent that you have attached to an expression or a term is known as a degree. It's basically the power of it. So we have the 4th degree, the 3rd degree, the 2nd degree, and the 1st degree. Right? So we will need to know those words and hopefully use them to help classify some things. All right, for the next part of your vocabulary, we have to name polynomials based on two different things. The first group that we have to name is based on the terms. How many terms are in the problem, right? And these are your nomial words. And in Latin, if you know anything about Latin, the word nomial means term. Okay, so these are all got a prefix that you can relate to things you know, and then it has the word term in Latin behind it. Okay, so for the first one, monomial, that's how you say that. Mono is a prefix, means one. So this is one term, right? So this is a polynomial with one term. Remember, terms are separated by plus and minus signs, right? So if it's a polynomial with one term, an example so that you have something to visualize would be something like 5x to the 9th power. Okay, there's nothing separating the 5 from the x to the 9th power. It's all held together by multiplication. So it is not separated into separate terms, and that is a monomial. Okay. The next one has the prefix bi in front of the nomial word, right? Like just like in bicycle, you have two tires or two wheels. A binomial is a polynomial with two terms. Okay, so an example of that would be something like 3x to the third power minus 2. Okay, the 3x to the third power is one term, and then the negative 2 is a separate term, so that's two terms. That's a binomial. Right? The third word that you're going to see has the prefix tri in front of it. Okay? Trinomial. And if you remember back to your days when you were younger and you had a tricycle, it had 3 wheels on it. Okay, so this would be a polynomial with 3 terms. Okay, an example of that would be x squared plus x plus 5. Okay. And notice that when I'm writing these examples, I'm also putting them in the correct format in standard form because that's how they're written. You don't ever want to have them out of order. Right? And then the last word in the nomial family is polynomial. Right? And if you know anything about the word poly or the prefix poly, it means many. Right? So in this case, this is a polynomial with 4 or more terms. We don't have any more special names once it gets 4 or higher, right? So we just call it a generic polynomial, right? An example of this would be something like x to the 4th minus 2x cubed plus x squared minus 5x. Okay, I have 4 terms right there, and that's known as a polynomial. The example I gave you up above in polynomial in standard form, that's a polynomial. It has 5 terms in it, so that would still be classified that way. Right. The other way you're going to have to classify a polynomial is by its degree. And remember that degree is another word for the exponent. It's the power of the exponent. Okay. And we're looking at the highest power in the problem, not just any old power. Right. So for constant, when something is constant, it's never changing. Right. So this would be the term with a degree of 0. In other words, it doesn't have a variable, right? So an example of this would be just the number 7, right? If you really wanted to think of it in terms of why do you not see the degree of 0, this is really 7x to the 0 power, and every single one of you should know that x to the 0 power turns into a 1, so it leaves you with just the 7. So you're never going to see the letter there because it's technically not there, but it does have a degree of 0 because of that reason. All right, linear. We've done a whole lot with linear, and every time you had to do a linear equation, right, your variable had a power of 1. So this would be a term with a degree of 1. All right, so an example of that would be 7x. Okay, the degree associated with the x is a 1. Okay, quadratic, right, is not what you think of with the prefix quad. You need to be very, very careful when you come down to that and trying to think of an easy way to help you out in remembering it. I do have a separate way that I'll share with you in a moment. Quadratic is when your highest degree, so a term with a degree of 2. In other words, the highest power that ever exists in the problem is a 2. And these will be our quadratic equations that we actually start graphing here shortly in the upcoming units. So an example of quadratic would be 3x to the 2nd power. It has to have a high power of 2. Right? Now, the easiest way to remember this so that you don't get confused is do not think of the word quad. Think about how many a's are in this problem. There's 1a and there's 2 a's. So if you use that trick to help you out, then quadratic has to go with a power of 2. That's about the best trick I've got to help you keep them straight. Right? For the next one, it's cubic. Right? And if you think about when things are cubed in math, right, or even a cube is a 3-dimensional shape, this would be your term with a degree of 3. So the highest power. So an example with this one would be anything in your expression that has the highest power being a 3. So like x cubed plus 7. Right? Even though I have more than one term, the highest power of the expression is a 3, which makes it a cubic polynomial. All right, the next one is the word quartic. And if you think of it as a part of the word quarter, it takes 4 quarters to make a dollar. So this would be your term with a degree of 4. So the highest power has to be a 4, right? So for example, if I have 8x to the 4th minus x to the 3rd power, Okay, the highest power is a 4, so this would be a quartic example. Okay, and then the last one on this vocabulary part would be the word quintic. And if you know that quintuplets are 5 babies, then anything with the word quint in front of it is going to be dealing with 5. So this would be the term with a degree of 5. Okay, so the highest power would be a 5, so an example of this could be something as simple as negative 7x to the 5th power. Right, so you're going to have to train yourself to know these words, and you're going to have to start thinking about them and memorizing them and making sure you know the difference, because I will be asking you to identify expressions based on these names. Right, I will tell you that quadratic and quartic are the 2 most commonly confused names because you get them mixed up. So come up with a way in your mind, whether it's the one I used or whether it's one you come up with on your own, to separate them and to remember them correctly. Right, if you flip your paper over, right, we are going to fill in certain pieces of this because this is what you're going to be practicing in class after seeing this video and digesting the notes a little bit. You're going to have to deal with a chart, and the chart is going to have different columns, and the columns are going to have labels on them that apply to each problem. Right, so I'm going to do a couple of the problems in the chart, and then you're going to fill in the rest, and then I'll do a couple of the problems below, and you'll do those as well. Right, so I'm going to take the first one, which is just the number 7, and it asks you what is the degree, which means what is the highest power it's got. It doesn't have an x, so that means that the highest degree is a 0. Right, because of the highest degree being a 0, this is what is known as a constant. And then if I'm looking to name it by term, that would be my nomial words. Right, so if you want to make sure that you put this up there to remind yourself, these are your nomial words. And because there's only one term there, this would be known as a monomial. Right, so jump down to, let's number these, 1, 2, 3, 4, 5, and 6. Jump down to number 4 for me. Okay, if you look at it, the highest power in the problem is a 2, so that would be a degree of 2. And because it's a high power of 2, that means this is known as a quadratic polynomial. And if you count the number of terms, there are 1, 2, 3 terms, so this would be known as a trinomial. Okay, so using the vocabulary and using what you know, see if you can fill in the rest of this chart, and we'll check in class and see how well you did. If you go down to the last section of the notes, right, you are going to have to be able to add and subtract these things together. We will also be multiplying and dividing them, but for right now, we're going to take it one step at a time. There are 2 reminders that I would like for you to remember as you do this. First and foremost, only like terms may go together. It's like combining like terms is exactly what we're doing here. Okay, so that's a must, is that you can only combine x squareds with x squareds, right? Second thing, if you are subtracting 2 polynomials, this is the key point because everybody misses the subtraction problems because of this one reason right here. If you are subtracting 2 polynomials, you must first distribute the negative sign to the second set of parentheses before you continue. So I will do numbers 1 and number 2 with you, and then you will be responsible for the rest, and we'll check them in class. So for number 1, you have a binomial added to another binomial, right? So we want to combine them together and make a final answer. Remember, your final answer must also be in standard form in the correct order, right? So I'm going to start with my like terms with the highest exponent I've got. I've got an x squared and a positive 2x squared. So 1x squared plus 2x squared gives me a 3x squared. Remember, your exponents are not changing, you're just adding the coefficients together. It's a lot different than the properties we just did with exponents that you were just taking your test on. Then I don't have any single x's, which is who would come next. So if I don't have any, I just skip over it. I go to what I do have. I have a constant of -7 and a constant of +2. They're going to join together. -7 plus 2 gives me a -5. So this is my final answer from what I did after combining those 2 together. Okay. Now, number 2, you'll notice it has a subtraction sign right here in the middle of your 2 polynomials. You have to distribute that negative to everybody behind that minus sign. Otherwise, the problem will not come out right. Right? So I'm going to rewrite the first part, 12x cubed plus 10, because that's not changing. But when I go to distribute the negative sign, essentially what you're doing is changing all the signs after in that other parenthesis. So instead of positive 18x cubed, I now have minus 18x cubed. Instead of minus 3x squared, I now have positive 3x squared. And instead of positive 6, I now have minus 6. Now I can combine my like terms, starting with my highest power first. So if you scan through the problem, you're going to see that the power of 3 is the highest one. So this is definitely going to be a cubic problem if you're naming it. If we have 12x cubed and we join it with minus 18x cubed, remember a sign in front of the number goes with the number that it's sitting in front of. 12 minus 18 is going to give you negative 6x cubed in your answer. Then you go to the next one, which is x squared. You'll see that I have positive 3x squared, but nobody goes with it. That doesn't mean you drop it out of the problem. You put it in the answer right after the x cubes because that's where they go in terms of the lineup. If it has nobody to go with it, it still goes in the answer. Then you go to single x's, which I don't have any, so that's when I get to leave it out. And then the last pieces I have are a positive 10 for a constant and a minus 6 for a constant. Positive 10 minus 6 is going to give me a positive 4 as my final constant. So in my final answer, I have negative 6x cubed plus 3x squared plus 4. Right, so that would be a cubic trinomial if you were naming it for me. So take some practice with these, but be very careful with those subtraction signs. Anytime you see one, distribute it to everybody after it in the parentheses, and then focus on combining your like terms.